Good morning, guys. It's 18th of July. We're going to record a short session. Most of you did well on your exam 3. Unfortunately, I won't be able to directly interact with you today, but I will record the session and I will see you tomorrow at the same time. And that's going to be July the 19th. Okay. So I would give you the link to this video. I would ask you to watch the video. And what are we doing? We're going to continue our work on this packet. Just want to make sure that I am recording. So give me 1 second. Okay, guys? Okay, I think things are going well. All right, so just to remind you, we are working on volume and surface area 1, and we finished up to problem number 14. So since, and I'm going to give you a little bit of background. Okay, I'm not in Valdosta. I'm in Florida. So I'm thinking I'm just going to record a session and you will watch it. That's how we're going to do it today. From tomorrow, I will be available. So we won't have an office hour today, and I will link it on BlazeView so you would know. So we did up to 14, and that was your syllabus for exam 3. We're going to work on 15, 16. Let me see how many I can do today, okay? That's the plan. And if you don't understand parts of the video, that's okay. You can ask me tomorrow questions. So that's the plan, guys. I hope things are well with you guys. So, I'm going to take this problem, you know the ritual. I'm going to take it to Mathigon Polypad and I'm going to work on the problem with you guys. Okay, so these problems are slightly more challenging than the ones we did because you cannot see the cubes. So let's read the question here first. The figure shows, oh, I don't like it. The figure shows, let's put an S here. Okay. All right, here we go. The figure shows the dimensions of a pedestal made with 4 layers of marble. So we have 4 layers, okay? And each layer is a rectangular solid that is 1 foot high. That tells me this pedestal is 1 foot high, okay? It's not in the picture, but it says that. So from this and the given dimensions, you will have to understand that these are basically a unit cube, and each unit is 1 foot. And you have to understand that. I am going to draw it today, but do you have to draw it? Not really. And my drawing won't be perfect, but you get the point. What I'm trying to explain, guys, to find the volume, I need to know the bottom unit is a 4 by 1. And of course, you can draw the cubes, count the cubes, but we have done those enough. I'm just going to say the bottom one is 4 times 4 times 1. Volume of the bottom slab is 4 times 4 times 1, which is 16. And the volume of the slab above it is 3 times 3 times 1. Let me see what I can do. My mouse is acting a little funny. Give me 1 second, guys, okay? Much better. 3 times 3 times 1, which is 9. And you can see the pattern. This is 2 times 2 times 1, which is 4. And the top one is 1 times 1 times 1, which is 1. If you add them all up, you're going to get 9 plus 1 is 10, 10 plus 16 is 26. You're going to get 30. So the volume is going to be 30 foot cubed. And that's our first part. I will check my answer. So just to make sure I didn't mess anything up, let's check the answer to number 15. Yeah, that's 30 square foot. Okay, the surface area. So I'm going to get rid of my writing. I need the room. The surface area, the way we're going to do the surface area, we're going to do it in a slightly clever manner, okay? And you want to observe these strategies because they come in very handy. The bottom square that you cannot see is a 4 by 4, that's 16. All right, of course it'll be square foot. I'm not going to worry about it right now. Okay, so is this, all the red stuff here, all the red stuff, if you carefully add them, you're going to get 16 because they really are on the top of that 4 by 4 slab in the bottom. Okay, there's a 16 in the bottom and there is 16 here. Let's write it down. And that's 16. All right, what happens here in this side? If you try to visualize it, you're going to get 1 square for the top cube, 2 for the bottom, 3, 4. 1 plus 2 plus 3 plus 4 is, I think it's 10, but I'm going to check it again. 1 plus 2 is 3, 6, 10. That's right. And the same thing goes on here. 10. Now this one is a little tricky, not really that bad. So is this 1, 2 squares, 3 squares, 4 squares. I have 10 here. And let's do one more. I have 10 here. And let's be consistent. Oh, that's okay. I mean, you get the point. That's just the arrow. I have to add them all up. What's 16 plus 16? That's 32. And I have 10 4 times. That's 40. And when you add 40 to 32, you get 72 square foot or foot squared, doesn't matter. That's your surface area. Now you have it. You have the volume, you have the surface area, and the surface area is correct because we just saw our answer 2 seconds ago. So that's number 15. We wrapped up number 15. Let's see what's coming up. And you're going to see in this packet, problems are going to be gradually getting a little more difficult, but nothing beyond us. Okay, so let's try number 16. Let's try number 16. This one is a little tricky. All right, actually, this one is not that tricky. This one is very basic, but the next one is builds on this and is tricky. Not really that tricky, but it's a little more challenging. Let's see what we can do here. Let's take the picture / problem to the other page. All right, here we are. The solid shown below is made with identical unit cubes. Find the volume and the surface area of the solid. Well, you just have to know how to find the surface area and the volume. Volume is very easy. These are unit cubes because each cube is 1 by 1 by 1. Okay, these are unit cubes. How many of them are there? The volume is going to be, I'm just going to count it like so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The volume is going to be 15, and that's pretty easy. And the unit is going to be 15 cubic feet. And the surface area is going to be counting the squares. All right, and we're going to do it very carefully. I'm going to erase all the marks here. Oops. Unfortunately, guys, I'll have to bring the picture again, but that's okay. All right. Let's take our picture. All right, how do we find the surface area? Again, the surface area is counting the number of squares that are on the surface. I'm going to count the ones that are visible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm going to write 19 here. This 19 will be a part of my surface area. Now I'm going to count the squares that are not visible to me, but I can kind of see it in my mind's eye. This has to be 6. It's a 3 by 2 rectangle. This has to be also 6. Okay, the bottom, the back. Okay, this side is going to be 7. It's like this side. It's just like this visible side. Right, that's easy to see, even though you can't see it, but you know it's going to be identical to this, the one you can see. Now add them all up. I already have 19, the green dots, plus 6 plus 6 is 12. 12 plus 7 is 19. And 19 plus 19 is 38. And that's my answer for surface area. And the unit is square foot. I'm going to go check my answer. Give me 1 second. We got 38 and 14, I believe. Yeah, that's a good sign. We got it right. Now, we're going to do number 17. The catch is for number 17, you kind of need number 16. So don't forget the answer to number 16. And we're going to do a little trick. Give me 1 second. Okay. So I'm just going to write my answer to number 16 is 38 for surface area and 14 for volume. I'm going to take this. Again, this is not my answer, but I'm going to use it, and that's very important. All right, so this is my answer to number 15. I know you haven't even seen number 17, but let's try it. All right, here is our problem. Now, why is number 17 so connected to number 7? Why is 17 very similar to number 16? Well, the picture is identical. We're going to soon see it. The picture is identical, except for the cubes are not unit cubes. What are they? They are 2 by 2 by 2 cubes. Okay, so one thing you have to understand, your volume and surface area depends on unit cubes, number 1. Number 2, that these are my answers to number 16. Okay, now you have to ask yourself, it's the same structure as the previous one, except for the cubes are not unit cubes, they are 2 by 2 by 2. What does a 2 by 2 by 2 cube look like? Well, that's what it looks like. I'm going to draw it here. All right. Now, you do have to understand a 2 by 2 by 2 cube is nothing but 8 unit cubes together. That's all it is. Okay, so the volume of my number 17, and you really want to make that connection, okay? Volume, my number 7, problem number 17 is going to be my 14. How many 2 by 2 cubes are here? The answer is 14. I can count them like I did before, but I have to this time multiply it by 8. Why 8? Because a 2 by 2 by 2 cube contains 8 unit cubes. I just showed a picture right over there. Of course, my picture is not perfect. So 80, I'm just trying to calculate 14 times 8 is 80 plus 32. I believe, if I'm not mistaken, 112. Okay, I'm going to check it once again. I think that's correct. All right, now surface area is a little tricky. Okay, you're asking, of course, we know how many squares are exposed. The answer is 38. That's the answer to number 16. But each square, which is a 2 by 2 square, is actually made of 4 unit squares, not 2, but 4. A 2 by 2 square has an area of 4. You can remember it that way. So what's going to be the surface area? The surface area is going to be 38 times 4. And that's going to be 152. I will double check. If I'm wrong, we'll catch and fix. Let me see. 4 times 38 is, that sounds about right. And let's go check our answer. And then I'm going to give you a little recap of what we did, okay? 112 and 152 is what we got. Yeah, that's about right. It's actually correct. So again, if you are given a set of cubes that are not unit cubes for the volume, here's a little bit of summary, okay? If you're given a structure made out of cubes that are not unit cubes, it could be a 2 by 2 by 2, it could be a 3 by 3 by 3. What would you do? You would pretend the solid is made of unit cubes, and you're going to find the volume, you're going to multiply it by, if it's 2, it'll be 2 cubed, which is going to be 8. And for the surface area, you're going to pretend it's made of unit squares, and you're going to find the surface area. Whatever you get, you're going to multiply it by 2 squared. For instance, if I give you this problem and replace this 2 with 3, this 2 with 3, this 2 with 3, I'm going to show you, I'm not going to do it for you. And if you want me to do it, we'll do it tomorrow. I'm going to multiply this 14, there are 14 cubes, by not 8 this time. Let's change the color. Not 8, but this time it's going to be 27, because 3 cubed is 27. What am I going to multiply? 38 for surface area. There are 38 squares on the surface. I'm going to multiply it by not 2 squared, which was 4. I'm going to multiply it by 3 squared, which is 9. Of course, my answers will change, but you know what I mean. So make sure you understand this. And if you don't have any questions, that means you probably do understand. But if you do, you have to ask me. Okay, I'll be happy to do one more sometime, and we'll come up with more problems and change it and give you 1 or 2 more examples. Okay, so let's move on. Let's do one more problem from our packet. All right, let's see what's going on. Now, this one is very easy. I will do it. We have discussed it many times. Let's see if I can grab a cube here. This will be sufficient. All right, this is a very basic problem, and we have discussed it many, many times, but we'll do it. No big deal. All right, how many faces does a cube have? Well, that's very easy. 6, face 6. How many vertices? We have discussed that many times. 8. 4 on the ceiling. 1, 2, 3, 4. 4 on the floor. 1, 2, 3, 4. How many edges? And edges are going to be, edges are going to be 12. 4 on the ceiling, 4 on the floor, and 4, I said, between the walls. Okay, it's a knowledge that it's a piece of idea or information that comes in very handy when you're solving some geometry problems. So that was number 18. See what else is coming up. All right, let's try this one. This is a good problem. I don't think we have done one quite like this, so be a little patient. We're working on number 19. We are working on number 19. Let's bring this guy here. Okay. Assume the large block shown below is a cube that is 3 units on each edge. So what we're being told, guys, is this is 3 units. Sure. 3 feet, 3 inches, doesn't matter. The large cube was cut into unit cubes. So if you cut it into 3 pieces, each piece will be a unit cube. It's really equivalent to taking a bunch of unit cubes and forming a cube that's 3 by 3 by 3. What's the increase in surface area? So we'll have to be a little patient. What we're going to do is try to find the volume of this solid, and we'll write it nicely. We'll say volume of the original 3 by 3 by 3 cube is, of course, it's 3 times 3 times 3, which is 27. I'm not going to worry about the unit. I like to put my unit in the final answer. All right. Now, that information, that piece of information comes in very handy. What you know is this now, that when you cut up when you cut up this big cube into 27 little cubes, each cube will have all 6 faces exposed. Now visualize this all by itself. What will be the surface area of this loose cube? It will have a surface area of 6. Each face is a 1 by 1 square. There are 6 faces. So let's write that down. After cutting up, my computer is acting a little funny, but we'll fix it. Okay. After cutting up, okay, each unit cube will have a volume of 6. There are 6 faces, and there are 6, let's make it a little bigger. There are 6 faces, and the volume of each unit cube will be clearly 6. Now, how many little pieces of unit cubes would you really have? You're going to have 27 unit cubes. This large cube has 27 unit cubes. When you cut it up into unit cubes, you're going to get 27 of them. So what will be the total surface area of those 27 cubes? Let's write it down nicely. The total surface area of the 27 unit cubes will be 27 times 6, right? Each cube has a surface area of 6. 27 times 6 is, let's find out what that is. 27 times 6 is 120, 162. I'm going to check it once again, okay? I think that's about right. Okay. So what's the increase in surface area? Well, the new surface area of the 27 loose cubes, we'll put it here, is this. And the original surface area of the whole 3 by 3 by 3 cube is this. What's the increase? 162 minus 162 minus 27. Let's just do it on the calculator. I know it can be done by hand in your head. 162 minus 27. I'm getting 135, and we have to check our answer. That's our answer, 135. What's the increase in surface area? 135 square units. And that's how we're going to write it. Now we're going to find out if I goofed or not soon. Oh, great. Number 19. Let me see. This large cube is, what is the increase in surface area? Okay. Now maybe I'm going to check it. Increase. Okay. All right, guys. I made a tiny error and we're going to fix it. We're talking about the surface area. The surface area of the original cube. This is the volume and everything is fine. We do need the volume, but let's find the surface area of the original cube. Let's erase this. Okay. The surface area of the original cube before it was cut up is going to be, let's write it right here, the surface area of the original cube is equal to, each face is 954. Okay. And the surface area of the little cubes is 162. These are the two quantities that should be compared. 162 minus 54 is going to be my answer. And let's see what it is. On 62 minus 54, what do we get here? 162 minus 54. And that's a good sign. That's 108. That's our answer. So be a little careful. Don't make the mistake that I made. 108 square unit. That's correct. All right. So we did 19. Let's do one more. Let's do one more. Let's finish up to 20. And that'll be plenty for today. Okay, let's try this one. A cube and a rectangular solid are equal in volume. If the lengths of the edges of the rectangular solid are 4, 8, 16, what is the length of an edge of the cube? I don't think it's that difficult, but let's do it. Okay. So this is going to be a problem where we don't have a picture, and that's okay. What's the volume of the solid? Volume of the solid with a rectangular base. Okay, that's what we mean. Solid, rectangular, solid is going to be 4 by 8 by 16. And I'm just going to use my calculator. And 4 times 8 times 16 is 512. What does the question say? What is the length of an edge of the cube? Well, I am pretend you have a loose collection of loose 512 cubes. Okay, you're going to take those 512 unit cubes and structure them in such a way so that you get a big block of unit cubes forming a bigger cube. So what we are really trying to say, guys, is what the volume of your new cube, let's say it's X, you can say X times X times X must be 512. Must be 512. Now, That means x to the power 3 is 512. And to find the value of x, you take the cube root of both sides. So x is the cube root of 512. And I'm just going to use my calculator, okay? And what's the cube root of 512? We'll find out. It's 8. And it should be a whole number. The answer is 8 inches. And let's check our answer. 20. So just for the record, we did up to 20. We can do some more. I'm going to wrap up today. And once again, I'm repeating myself. Take a look at this video. I will see you tomorrow at 11:30 as usual. Today, there won't be any office hours. I won't be there, but I would encourage you to watch the video and do all the problems up to 20. If you have any questions about the exam, we'll be happy to answer them tomorrow. All right. Thank you, guys.